This is Unit 2, Day 4, example 29. The function y equals f of x is shown graphed to the right. So here's our function, okay? State the y-intercept. Well, remember, the y-intercept is where it crosses over the y-axis. So our y-intercept is 0, 2. Please write it out as a coordinate. You should always be giving me an x value and a y value. All right, state the x-intercepts of the function. What are the alternative names? You must know this, that we give the x-intercepts. Okay, so x-intercepts are also known as roots or zeros. Okay, sometimes you can spell zeros with an E in there too. Okay, so now the x-intercept is where they cross over the x-axis. Again, name them as a coordinate. So all x-intercepts are when the y is equal 0. So it's going to cross over at 4, 0 and at negative 6, 0. Okay, so notice something. Y-intercepts have x equal to 0. X-intercepts have y equal to 0. Part C. Over the interval, so they want you to look at when x is negative 1 all the way to 2. So ready? Here's negative 1 all the way to positive 2. Okay? And it wants to know, is that increasing or decreasing? So look at this graph right here. There's over the interval from negative 1 to 2, it is clearly increasing. How can you tell? Well, the y values are going up. Okay? The y values are going up. Okay, part D. Give the interval over which f of x is greater than 0. You must know, when numbers are greater than 0, they're asking for when it is positive. In other words, give the interval for which it is positive, okay? So greater than 0 means positive. Obviously, less than 0 would mean negative, okay? So anything above the x-axis would be a way that you could look at a quick way of seeing this visually. So anything above it. So looking at the graph, when does it rise above the x-axis? All the way from here, okay? So where I'm tracing over here, that's when it's positive. So you want to find the value from here all the way to over here. Okay, so my x, you're at 1, 2, 3, 4, 5, you're at negative 6 to positive 4. So you're from negative 6 to positive 4 is where it is above the x-axis, which means it's positive. So you're going to go from negative 6 to positive 4. Now the original parameters they gave us was not equal to. So you do not include those, so those are smooth brackets. Okay, so it's from negative 6 less than x less than positive 4. Part E, state all the coordinates of the relative maximums. Okay, relative maximum means name all the highest points on the x's. So if I go to this graph here, okay, this is the easiest thing. This is going to be a minimum. This is a minimum. And this is a minimum. So there's 3 minimums there. Okay, there's 3 minimums. Okay, the maximums are, here's a maximum, here's a maximum, but here's a maximum as well. So you can see even the tails of the graph have a minimum and a maximum. So now that I have those highlighted for you on the graphs, now I'm just going to list their values, and it does say the x coordinates. Okay, so the maximums are all the high points that I have in the blue, and your x values are at negative 4, positive 2, and 6. The minimums are the low points that I have in red on the graph. So that's at x values are at negative 8, negative 1, and 5. Okay? What are the absolute maximums? That means the highest of the high. Okay, so my maximums were negative 4, 2, and 6. Okay, so what's the highest one there? It's at 2, okay, for that x value, but I'm going to give it as a function of x and y. So for the y values, okay? When x is 2, the max value, so just go look at that high point. So if you go look when x is 2, that highest point, your y is at 8. So that's why the max value is at 8, okay? And the absolute minimum value would be the lowest of the low, which is going to be at -8. But again, that's the x value. So when x is at -8, then you're going to give me the minimum value. Again, it's the y value paired up with -8 is going to be at -4. Okay? So these are kind of like the coordinates. 2, 8. And -8, -4. But remember, you need the y values for the maxes and the mins, okay, because that's the up and down, the range. State the domain and range of this function using interval notation. You have to know interval notation means square versus smooth bracket. So do you include or not include them? Okay, so the domain goes all the way from -8 to +6, okay, and the range goes all the way from, oops, that's included, -4 all the way to +8. And again, domain you're reading from left to right, range you're reading up and down. Moving on to example 30. So it gives you this g function, which is 2 times the absolute value of x minus 8 quantity minus 8 defined over the domain. Okay, remember, the domain means use the x values from -4 all the way to +7. So what I did in a case like this is I kind of just went to my graphing calculator, I put this in the graph page, and then I produced the table of values. Okay, that's always something really, really nice to look at. Okay, I know that the x values have to go from -4 all the way to +7. There's a lot of them. There's a lot there. And then I just copied the table. So it was 2, 0, 2, oh, I'm sorry, 2, 0, -2. -4, -6, -8, -6. You can see it turning around right now. -4, -2, 0. See that pattern? 2 and 4. Okay. Sketch a graph of this function to the right. Again, put it in the graphing calculator. Get its table of values. Okay. So let me plot these really quick here. So use those table of values. Okay. All right. All right. Now, do not draw arrows on those, because arrows would mean it's continuous, and when they gave a specific domain, so don't do this, okay? You cannot do that. They gave the specific domain, so you could just call this the g function if you didn't want to write the whole thing down there, okay? State the domain and range over which the function is decreasing. Now, decreasing means going down, so you guys can see that it's going down right here. So you have to read the domain means its x values. So tell me, what are the x values? All right, so it is going down right here. Well, what are those x values? So you read from here to here. The x values. So it's from -4 to +1. Okay, I just want to get that blue off my page here. Okay, so it's from -4 to +1, and they're both included. Okay, state the zeros. Zeros mean the roots, the x-intercepts. That's where they're crossing over the x-axis, okay, from this interval. So, I didn't mean to do that. Uh-oh, I didn't mean to do that either. What am I doing? Sorry, guys. Let me jump right back down to that. Oh, here we go. Okay. So we have to name those roots right there, and those are in the red circles. So I just have to name those roots, and that's, remember, just the x value. So it's at x equals -3, and x is your +5. I didn't give those as coordinates. It just wanted the zeros, which are the x values. State the interval for which it is greater than or equal to 0, which means when is it positive? Okay, so this is positive, right? Oop, I didn't mean that. Positive means above the x-axis. So there's where it's above the x-axis in yellow. Okay, so I have to name when it's above the x-axis. So how do I read that? Well, that's from a -4 to a -3. So you're kind of reading it over here like this. It's from -4 to -3. Okay, this one, it's from 5 all the way to 7. Okay, so those colors hopefully helped you out here without me erasing the whole graph. Let me try and do this again without getting rid of all of that. Okay, so from -4 to -3, it was sitting above the x-axis, and from 5 to 7, it was sitting above the x-axis. All right, evaluate g of 0 by using the algebraic definition of the function. What does this correspond to on the graph? All right, well, at 0, so when x is 0, remember, this means when x is 0 right there. Well, it's down here at -6. So we say g of 0 is -6. Okay, this is known as your y-intercept. So when x is 0, it's your y-intercept. Last example here, example 31. A continuous function f of x has a domain, so all my x values are from -6 to +13, with selected values shown below. The function has exactly 2 zeros. Now remember, zeros are the x-intercepts, and the x-intercepts are when y is equal to 0. So just looking at this, I know that right here's a 0. That's a 0 right there. And this is also a 0. Zeros mean x-intercepts, okay? X-intercepts mean when y are 0. It also has 2 turning points, one at 3, -4, and one at 9, 3. Okay, so how do you know they're turning points? Because that's when the values are either going up and all of a sudden they start going down, or when they're going down and all of a sudden they start going up. Okay, so to state the interval for which f of x is less than 0. Less than 0 means negative. So look at your table of values. When is it negative? Okay, it's negative right here. So it's between -1 and 8. Okay, so between -1 and 8, they have to be smooth. Why do they have to be smooth? Well, it's not equal to 0. If it said equal to 0, then you can include the -1, which would put a square bracket on this side. Okay, it is not equal to 0, so you cannot include the 8, so you have to use the smooth parentheses. All right, state the interval for which f of x is increasing. So when is it going up? All right, well, it looks like, so if you're here at 0, so you're at 5, then you're at 0, then you're at -2, so you're going down. Okay, -4, you're still going down. But then all of a sudden, -4 goes up to -1. So it starts turning around right here from x values from 3 to 5. Okay, when does it go up? Well, look, from here to here it's going up, then it continues to grow. So from 3 all the way to 9. Oops, I'm sorry, this one went down again because 3 went down to 1. So from 3, right here, all the way to 9, these values were increasing. So from 3 to 9, but again, you cannot include them. Okay, so you got to use your smooth parentheses. That was increasing. Okay.